This is lesson 7.1 part 2. In this video we will learn how to model exponential equations. So this is the formula that we will use for modeling exponential growth and decay functions. In this model we have a of t, which is going to be the amount at the end of some time period. A, lowercase a, is going to be the initial amount, the amount we start with. R is going to be the rate of growth or the rate of change. The R value needs to be written as a decimal. So if you were given a growth rate of 5%, you would write that as 0.05. And then T is the amount of time. The amount of time has to be written in the same vein as the rate. So if it's a 5% annual growth rate, the time has to be written in years. If it's a 5% monthly growth rate, then the time has to be written in months. So if R is a number greater than 0, in other words, a positive value, then we're talking about a growth function. And if R is less than 0, or in other words, negative, then it's a decay function. So R cannot be equal to 0. So here we have an example. Suppose we want to invest $1,000 in a savings account and the account pays 5% annual interest. How much money will we have at the end of 6 years? So using our formula, we're looking for A of t, the ending amount, after a period of time, and that time is 6 years. So we're looking for the amount at the end of 6 years. Our initial amount is $1,000. And our interest rate is 0.05, which is an annual interest rate. So then t has to be written in years because the percentage rate was in years. So that goes to the 6th power. This you just calculate in your calculator. And we get $1,340.10, rounding to the nearest cent. The other thing that we can do with this exponential growth modeling is, instead of deciding ahead of time we're going to leave the money in the bank for 6 years, we can ask, well, how long would it take to reach a certain dollar amount? In that case, our ending amount is going to be $1,500, given here. Our starting amount is still $1,000, and our interest rate is still 5%. So what we're solving for is t. So to solve this equation, we're going to, since we don't have the skills yet to solve an exponential equation, we're going to make an xy table. So I created an xy table here where I plugged in different values of x representing the years and calculated different amounts of y, which would be the amount of money. And we can see that right in here, between the 8th and 9th year, is when we will have $1,500 in this account.